Title of first section of notes is Evaluate. For a variable. Directions for this one are solve, when w equals 6, x equals 0.4, y equals 1/2, and z equals -3. First question, w plus 12 divided by z. Given the previous four values, we can plug in for the variables and then solve. For example, w equals 6, so we'll put a 6 in place of w. Plus 12 stays the same, and divided by z, z is -3, which I'll put in parentheses. This problem we have addition and division. If you remember PEMDAS, the order of operations, parentheses, exponents, multiplication, division, addition, and subtraction. We'll do division before we do addition. So 6 plus 12 divided by -3 would be -4, and 6 plus -4 equals 2. Second question and last question for the section. W minus 3x plus y, and we'll solve this using the previous values given. W again is equal to 6, 3, and instead of x we'll put the decimal value 0.4, and plus y, y is 1/2. Solving this, we have subtraction, multiplication, and addition. And again, we want to follow PEMDAS. PEMDAS, we're going to do multiplication first, and then we have addition and subtraction. -3 times 0.4. If you multiply that out, that'll be minus 1.2. And plus, instead of 1/2, since we already have a decimal, I'll change 1/2 into a decimal, which would be 0.5. Solving from here, keep in mind we're following PEMDAS. One step on PEMDAS that's most commonly forgot is multiplication, division, and addition, subtraction. You do each of these operations at the same time in order from left to right. So even though addition looks like it comes before subtraction, these are paired, and you do both operations in order from left to right. So we'll subtract first and then add. 6 minus 1.2 would be 4.8, and plus 0.5. Adding those together will give you the answer of 5.3. Title of the next section notes is More Evaluation. Directions are solve, when A is equal to 2/5, B is equal to -3, C is equal to 0.5, and D is equal to 6. First question, b to the fourth power minus d. Again, taking the four values given, we can plug in and solve. B is equal to negative 3, which again I'll put in parentheses, minus d, d is equal to 6. We'll do exponents before subtracting. Negative 3 to the fourth power would be negative 3 times itself 4 times. Negative 3 times negative 3 would be positive 9. 9 times negative 3 would be negative 27. And negative 27 times negative 3 would be positive 81 minus 6. Subtracting, and the answer would be 75. Second question and last question for the section. In parentheses, a minus c squared minus 2bd. Again, plugging the values in. A is equal to 2/5. C is equal to 0.5 squared minus 2. B is equal to negative 3. And D is equal to 6. Solving from here, we'll do parentheses first. 2/5 minus 0.5. 2/5 you can change to a decimal by using a calculator or long division. That is equal to 0.4 minus 0.5 squared. Subtracting these decimals would be negative 0.1 squared. Rewriting the rest of the question, we have minus 2, negative 3, and positive 6. Exponents we'll do next. 0.1 squared. If you multiply that out, that would be 0.01. And multiplying the rest of the numbers, negative 2 times negative 3 would be positive 6. Positive 6 times 6 would be 36. So we have 0.01 plus 36. So our final answer would be 36 and 1/100th. Solving this problem, we'll take the formula of the volume. Volume is equal to 1/3 pi r squared times the height. Given the information, r is equal to 3x and h is equal to 2x, we can substitute those in for the variable. So the volume would be 1/3 pi. Instead of r, we'll put 3x. I put it in parentheses since the quantity will be squared, and h would be 2x. Simplifying from here, following PEMDAS, we'll do exponents first. So volume equals 1/3 pi. Squaring the parentheses, we'll square the number as well as the variable. So 3 squared would be 9, and x squared would be x squared. And next step, we can multiply. 9 times 2 would be 18. 1/3 is like dividing by 3, so we'll have 18 divided by 3, which would be 6. Pi would stay the same. And x squared times x would be x cubed, or x to the third. So our final answer would be 6 pi x cubed.